as my habit is there, we are interested to cover the previous lecture. Yes, and the previous lecture is all about the schedule of rates, and you have to keep in mind whenever we are going to find out the schedule of rates, the rates are going to vary from place to place. Yes, so that is the important part which we have understood from this particular schedule of rates. Yes, so just a minute, let the uh, PPT is going into the slideshow mode. Yes, and this is the part which we have discussed in the previous class. Yes, so you have to keep in mind the rates are going to vary from place to place depending on the rates of construction of materials, the labor cost, and the working environment. Yes, and I have given you one best example that one institution wants to buy the chair, so they have to determine the specification first. After the specification, they have to find out they are going to take the plastic chair or the metal chair, and they have to find out the dimensions. Yes, so this part they have to determine first. And after finalizing these particular dimensions, material, and all the specification, best possible rates are to be estimated. Yes, so we have to go inside the market and we have to find out the which shop or which vendor, or you can say which company is going to offer us the chairs in a minimum possible cost. Yes, so that can be one method to get the schedule of rates. Yes, and I have told you that whenever we are going to say that this process of awarding any work, so it should be competitive. Yes, there must be a comparison between different vendors, different companies, or you can say different shops, and this process must be a transparent process. Because of this transparent process, we can limit, you can say, the आपण त्याला भ्रष्टाचाराला आपण त्याला आळा घालू शकतो. Yes, and this is called as the estimated cost. Yes, and believe me, whenever you are working in a government sector, you have to follow these ethics and these rules. Yes, and this is the part which we are interested for the today's lecture. Yes, I hope I am audible to you and my screen is visible to you. If you are persisting any problem, you can unmute yourself and you can speak. Yes, because see, if I'm not or you can say you are not getting my voice, then I have to go again back and I have to check my internet connectivity. Yes, so better way, you can speak or you can unmute yourself and you can speak. Okay, now here, just a minute, sorry. So this is the example which we are interested for the today's class. Yes, and the following loads are connected in a building. Yes, so the building consists of the two sub-circuits. So this is the sub-circuit 1 and this is the sub-circuit 2. Yes, and we are interested to find out the cable size. Yes, so just a minute. And in the sub-circuit number 1, there are two lamps, each of 1000 watt. 4 fans are there, each of you can say 80 watt. The 2 TV are there, each of 120 watt. Sub number circuit 2 consists of 6 lamps, each of 80 watt, 5 sockets, each of 100 watt, and 4 lamps, each of 800 watt. We know that inside the building or inside your house, we are using these primary needs. So lamp must be there to you can say, for the intensity of light, we need the lamps. Yes, fan must be there for the circulation of air. TV must be there for entertainment purpose. Yes, and to connect this TV, to connect these fans, we need the sockets. Yes, so these are the primary needs, and they have asked you if the supply voltages are 230 volt. Obviously, the case is of India, so we are taking the supply voltage that is the 230 volt. Then they asked to calculate the circuit current. They asked this particular component, and they have asked the second quantity, that is called the cable size for each sub circuit. So sub-circuit 1 and sub-circuit 2, we have to find out the cable size. But before that, we have to find out the circuit current. Yes. So we know that we are having the power capacity, and we are having the voltage capacity. We can easily find out the circuit current. Yes. So and they have given this particular table. So you are having, or you can say, whenever the numerical are asked based on this particular chapter, or you can say based on this particular concept, so they are going to provide you one data, and inside this data they have mentioned that current carrying capacity. So this is the first column. The second column is the number of wires of thickness. Just a minute. Thickness of each wire, and they have given the area also in inch square. Yes, it is not in millimeters. It is not in meter square. It is in inch square. Okay. Why this data is given? Because we know that depending on the catalog of particular cable, we are going to find out the thickness, or you can say we are going to find out the size of the particular conductor. Yes. So there must be the you can say the table must be provided to solve this particular numerical. Okay. So we are not interested in this particular table. After getting the calculation, we are going to see the table, and we are going to write the thickness of the particular wire, or you can say cable size. Yes. Now we are interested for the solution. So what is the quantity they have given for the sub-circuit 1? They have given that there must be the 2 lamps. Yes. Each of 1000 watt. Yes. They have given 4, I guess, just a minute. They have given the 4 fans each of 80 watt, and 2 TV each of 120 watt. So we are interested to find out the total load first. Yes. And we know that how to find out the total load. The quantity of a particular equipment multiplied with the wattage rating. Yes. And the addition of this particular different components will give us the total watt. Yes. Now we are interested to find out the current for a sub-circuit. Yes. So how to find out the current of sub-circuit? We are having the power rating, or you can say wattage rating with us. So this 2560 is the wattage rating, and they have given for the supply voltage of 230. We have to find out the current rating. Yes. So by division of this quantity with 230, we will get the current for the sub-circuit 1 is 11.1 ampere. Same way, we have to follow the same procedure for the sub-circuit number 2, and because of this sub-circuit number 2, we will see what are the equipments are there. So 6 lamps are there, each of 80 watt. So 80 watt into 6 plus 100 watt into 5 plus 800 watt into 4. So this can be the addition of all the power wattage, and it gives 4180 wattage. Yes. We have to find out the current for sub-circuit number 2, because they have asked to find out the circuit current for each circuit. Yes. So same formula we have to follow. I equal to P upon V. P must be 4180 divided by V is 230, which is a common. Yes. And after this, you can say the division, we will get the current as 18.1 ampere. So here your half numerical is finished. Yes. In the second semester, you are having one subject. Third year, second semester, you are having one subject, electrical audit, and you can say measurement. Yes, EAM subject is there, and inside that subject, you have to make the audit. Yes. So there is a scope of that particular subject is also might be you have heard the word Bureau of Energy Efficiency. Yes. So if you are thinking that you want to become an auditor inside the electrical field, so you must acquire the certificate first. Yes. And after that certificate, you are going to eligible to conduct the audit for a particular company or for particular residential complex. Yes. Now, what are the advantages of having the certificate of that BEE exam? So there is a exam is available which was conducted by Bureau of Energy Efficiency. So BEE. If you are thinking that you want to become an auditor inside the electrical field, so you must pass this exam. Yes, and the name of exam is Bureau of Energy Efficiency. Believe me, as an electrical engineer, we are having a tremendous scope. So one can think they can go in the field of electrical contractor. One can think they can become an auditor. Yes, but to pass this exam, you must study hard, because there are conventional papers also, descriptive papers also, and there are MCQ papers also for this. And some part are going to ask from mechanical engineering, and some part is going to ask from electrical engineering. Yes, because mechanical and electrical are allied branches, or you can say are dependent branches. So if you are thinking to study, or if you are thinking to pass or to score the good marks in this exam, so you must study the mechanical engineering also, some part. I'm saying some part of mechanical engineering, not all the subjects, but some subjects are there inside this Bureau of Energy Efficiency. So your concepts are very clear if you are thinking to become an auditor. Yes, same calculations are available for the auditor also, but in the, you can say, there are the softwares are available, and you have to just enter the data, and the result will be calculated at the end. Yes, so this can be one opportunity for you as an electrical engineer. Yes, but the minimum qualification is you must hold the degree of engineering. Yes, so after that you can become the electrical auditor. So if you are going to pass this BEE exam, okay, this can be one opportunity. We are interested to find out the cable size. So just we have found out the current for each subcircuit 11.1, and current for subcircuit 2 is 18.1. The numerical is not finished yet, because we have to find out the cable size. So therefore the cable suggested for each subcircuit is 1. How much cable circuit one consists of? It consists of the current of 11.1 ampere. So we have to look the table. So 11.1, which is beyond 11, so we have to take this 13 as a quantity, because we have to use the upper limit. Yes, so whenever we are choosing this particular amount of current, then this amount of 3 by 0.029, this can be the number of wire. So this can be a number of wire. This numerator indicates the number of wire, and this denominator indicates the thickness of each wire, and this is the area, 0.002 inch square. Yes, to convert in millimeter square, so you have to use the formula to conversion of inch into meter. Okay, and here you can see the cable suggested according to the table is this much. Yes, and the cable suggested for subcircuit 2. Yes, so what is the current? 18.1. So we have to look for the table. 18.1, it is not available in this table, hence we have to use the upper limit. So this is the upper limit for this particular current. Yes, so it is a 7 divided by 0.029, and this area must be 0.0045. Now here you can see, as the current increases, the area is also increases. So this is the direct relation between the current and the area of cross section. Okay, now we have to take the total current drawn by both the circuit. So if they have asked to suggest the cable for individual sub-circuit, then this is a sufficient answer. Yes, but they have asked to find out the cable for the main circuit. So we have to add the sub-circuit 1 and sub-circuit 2. So what is the current? 11.1 plus 18.1. So it is 29.27. Now we have to look the table again. Yes, for the 29.27, the size of cable is, it is not available 29. Yes, we are not going to choose 28 because our limit or our value is 29. So we must choose the upper limit. So after choosing this upper limit, so I have made the black circle. So the size of cable is 7 by 0.044, and the area of that particular conductor is 0.01 inch square. And here you have to write your particular answer. Yes, without table you cannot suggest the cable size. Yes, so whenever they are going to ask you the numerical, believe me, they are going to provide you that data, that particular data, and after that data you are going to suggest the cable. Yes, I hope this numerical is clear to you. Yes, so we will go ahead. Yes, we will see the second numerical, and after this I will ask you one question depending on this. Okay, if you are having any doubt, then you can ask me. Yes, here. So here we are interested for the second numerical. Yes, for the electrical wiring installation in a building, total load is 4.5 kW. Yes, so let me use the pen. So the total load is, they have given 4.5 kW. Yes, and total length of cable from energy meter to sub circuit distribution board is 35 feet. Now the change in the numerical, the same numerical are not going to ask repeatedly. So they are going to change you. They are giving the, you can say the length sometimes. They are giving the temperature sometimes, and they are going to ask you the most suitable size of particular cable. Yes. So we will read the numerical first, and then we will try to write the given quantities. Obviously, this is the case of India, and they have given the voltage as 220 volt. But if they are giving the voltage as 110 volt, so it is not the case of India. It is the abroad case. Yes. So in the abroad, or you can say outside India, the voltage range for the supply is 110 volt. Yes. And the temperature is 40 degrees Celsius. Find the most suitable size of cable from energy meter to sub-circuit if wiring is installed in conduits. Yes, might be in your house, the conduits wiring are already used. Yes, and to find out the size of cable, we have to do some calculation. Yes, now what are the calculation we have to do? The calculation are simple one. The total load is 4.5 kW. Obviously, K stands for 1000. So we have to multiply this quantity with 1000 watt. So the answer is 4500 watt. Yes. Now we have to consider the additional load sometimes. Yes. Why we have to consider the additional loads? Because we are installing the particular wiring. Yes, so we have to take care of the future load also. Yes, so we have to consider the 20% additional load here. So 20% of this particular total load. Yes, 4500 watt. Yes, so after this 20%, we have to multiply with the 20 divided by 100 factor. So it comes as 900 watt, and we have to add this 900 watt in our total load. So this can be our predicted load. Yes, this is the predicted load which can be available after some years. Yes, so if they are giving or they are asking you such that you have to install the wiring inside the building, so you have to consider this particular 20% additional load. Yes, so these are the small concept, and you have to remember this value as 20%. You have to add this 20% figure inside your total load, and then you have to find out the total current. What is the total current formula? It is a very simple. I is equal to P by V, and what is the value of P? P is the future load, which is a 5400 watt divided by 220 volt, and this value of the division comes as 24.5 ampere. Yes. Now I have not shown you the, you can say, the table here. Yes. So this is the table which is related to the current carrying capacity in amperes, the number of wires and thickness of each wire, and this is the area in inch square. Yes. And they have given this as a the current rating of copper cables at 30 degrees Celsius. This they have given. Yes. Now we have to select the size of cable for the load current of 24.5 ampere. Yes. So from the table 1, which comes as 7 divided by 0.036, which is for 28 amperes. So let me check. Now here you can see 24.5, which is not available inside this particular table. So we have to take the upper limit, and here I have made the box. And this value you have to consider for your calculation. Yes, 7 divided by 0.036. Yes, it means we can use 7 divided by 0.036 cable according to table number 1. Now, what do you have to check? We have to check the temperature range also. Yes. So here they have given again the second table. Sorry, this is the second table. Huh? So this is the print mistake. The temperature factor. Yes. What is the meaning of temperature factor? Because see, this table is of at 30 degrees Celsius, and in our numerical they are going to ask you for 40 degrees Celsius. So there must be one factor is available. Yes. So which is the factor? The factor is very simple. Here you can say check the selected 7 divided by 0.036 cable with temperature factor in table number 3. So this must be a table number 2. Okay. So the temperature factor is 0.94. So here you can see we are interested for 40 degrees Celsius. Yes. So it is in Fahrenheit 104 and it is in Kelvin 313.15, and the factor is 0.94. Yes. So the factor is 0.94 at 40 degrees Celsius. The current carrying capacity of this particular conductor size 7 divided by 0.036 is 28 ampere. Therefore, current carrying capacity of this table at 40 degrees Celsius would be, we have to find out now for 40 degrees Celsius. Simply, we have to multiply with this particular 28 ampere, which we have find out with this particular table number 1. Yes. So we have to multiply this factor with our 0.94, which gives us 26.32. Yes. Now the value of current is going to decrease. Yes. Why? As the temperature increases, the amount of current is going to decrease here. Yes. Now we have to again find out for the 26.32 ampere current. Yes. Now here you can see I have made the conclusion. Since the calculated value at 40 degrees Celsius is less than that of the current carrying capacity of cable, which is 28 ampere. Therefore, the size of cable is also suitable with respect to temperature. Sorry. Now here, what changes I have made? Just I have used this particular factor of 0.94. If we are taking 28, which is the maximum current limit, and we are going to find out for 0.94, which comes as 26.32. Yes, this 26.32 is not available in the table again. So we have to change, we have to use this upper limit. Yes, so there is no change in this particular value at 40 degrees Celsius. Yes, so we can choose this particular value. Yes, now there is a one difference in this particular numerical. Yes, now I have added one important part. Yes, so this can be a second B, or you can say this can be a B part of this particular numerical. Yes, it is not asked in your numerical, but for the study purpose, for the, you can say, for the knowledge purpose, I have used this particular part. Yes. Now what is the part? Now we have to find out the voltage drop for 100 feet. For this, that our cable size which we have find out 7 divided by 0.036 cable from table number 4. Now, where is the table number 4? So here is the table number 4. Here you can see for the current rating of 28, the voltage drop per 100 feet is 7 volt. Yes. So this is the table number 4. This must be a table number 3, and cable size, current rating with voltage drop. Yes. Because we have to take the calculation of voltage drop now. Yes. Is 7 volt. But in our case, the length of cable is 35 feet. Yes. They have given the length of cable is 35 feet. So this factor we have to consider. Yes. This is the factor. Therefore, the voltage drop for 35 feet cable would be, yes. So actual voltage drop of 35 feet. So 7, we have to multiply this quantity of 7 into 35 divided by 100. Yes. And we have to find out for 24.5 divided by 28. तुम्हाला कळत असेल आता की 100 साठी जर 35 असेल तर 7 व्होल्टेज साठी मला किती व्होल्टेज ड्रॉप लागेल. येस. सो ते फाइंड आउट केल्यावर दी क्वांटिटी येते ती येते 2.1 व्होल्ट. येस. नाउ अँड अलाउएबल व्होल्टेज ड्रॉप, एक अलाउएबल व्होल्टेज ड्रॉप पण मला कन्सिडर करावा लागेल की जो असेल माझा 2.5 into 220 हे जे माझे व्होल्टेज आहे त्या व्होल्टेजला मला कन्सिडर करावं लागेल and divided by 100, which is comes as 5.5 volt. Yes. Here the actual voltage drop is 2.1 volt. हा actual आपला calculation ने आला, which is less than of maximum allowable voltage drop of 5.5 volt. जो कि आपला हा maximum voltage drop आहे 5.5. Yes. Therefore, the appropriate and most suitable cable size is 7 divided by 0.036 for that given load of electrical wiring installation. Yes. म्हणजे आपल्याला काय करावं लागेल, हीच केबल साइज ची जो डायमीटर आहे किंवा जो एरिया आहे तो आपल्याला कन्सिडर करावा लागेल. कशासाठी? आपल्या इलेक्ट्रिकल इन्स्टॉलेशन साठी. न्यूमेरिकल मोठं जरी असलं तरी कुठेही घाबरून जाण्याचं काही कारण नाही. येस. सिस्टमॅटिकली जर तुम्ही गेलेत, सॉल्व्ह जर केलं व्यवस्थित, सो यू विल डेफिनेटली गेट द पर्टिक्युलर आन्सर. Yes. So what we have to do first? We have to find out the total load, which is a 4.5 into 1000, which comes as 4500. I'm repeating again. Yes. We have to install the electrical wiring. So we have to consider the additional load of 20%, which comes as 4500 into 20%. So obviously 20 divided by 100. So 900 watt. We have to add these values together. So this is the future load of 5400 watt. Yes. Same the formula we have to use for finding out the current P by V. So we have to consider this 5400 watt divided by 220 volt, which comes as 24.5. Yes. Now for the 24.5, the most suitable size is 7 divided by 0.036. But this is the value for 30 degrees Celsius. We are interested for 40 degrees Celsius value. Yes. So there must be a table is available. Yes. So for the 40 degrees Celsius, we have to take this temperature factor as 0.94. We have to multiply this 0.94 to 28. We are not going to multiply this 0.94 to 24.5 because inside the table we are taking this 28 as a maximum limit. Yes. So by multiplication of this 28 into 0.94, which gives us 26.32. Obviously, this value is also not available in table. So we have to use the upper limit 28. So the cable size remains same. Yes. But if the value is going to change after this particular, you can say they have given the factor as at 25. So now the value is going to change 1.02. Yes. After this value, we have to take the again next limit. So if you are going to multiply with this 28 with 1.02, so it is obviously greater than 28. So at that time you have to consider the 34 ampere current value. Yes. And last point is we have to consider the 100 feet voltage drop. Yes, so this is, they have given 7 for the rating of 28. Yes, so we have to find out for 35 feet because they have given the length of cable is 35 feet. तुम्हाला सिंपल कॅल्क्युलेशन करता येतात की 100 फीटला जर त्यांनी 7 व्होल्ट ड्रॉप दिला असेल तर 35 फीटला तो किती काढता येईल. सो द व्हॅल्यू बिकम्स ॲज 2.1. येस, आणि जर आम्ही त्याच्या 2.5% घेतलं कशाच्या मॅक्सिमम अलाउएबल ड्रॉपच्या, सो मॅक्सिमम अलाउएबल ड्रॉपच्या तो किती होतो 5.5. so we are not going to consider this value, we are going to consider the 2.1 value. Yes, and this 2.1 value is suitable, or you can say the actual voltage drop. Yes, and because of this the cable size is same 7 divided by 0.036. Yes, here you can see 7 divided by 0.036 for the value of 28. Yes, हा व्हॅल्यू इथून काढली 7 divided by 0.036. so this table and this table is the same. तुम्ही जर मागाचा टेबल बघितला असेल, हा टेबल आणि हा टेबल सेम आहे, याच्यामध्ये फक्त ऍडिशन केलंय या व्होल्टेज ड्रॉपचं. येस, नाउ आय होप यू आर going to understood this particular numericals, because in the exam definitely the numerical part are going to ask. So if you are going to take this numerical practice at your home, or you can say at your place, then you will definitely score a good marks. Yes, and believe me, so whenever you are going to consider this particular numerical, so numericals are very simple. Just you have to use particular formula, and based on the formula we can able to find out the maximum cable size. Okay, so if